Hit play and then just go.
Okay.
Okay.
So the basic idea is we used to think that HIV viruses came about by a cell being infected, the virus copying itself, millions of copies, and then the cell was so full of virus that it burst open, and the virus was spreading in between all the spaces between the cells and then infecting new cells. So the majority of medicines, drugs, have been targeting these free HIV viruses. Okay? But what we've discovered recently, we've been able to create a tag using green fluorescent protein, tag the protein coat of the virus, the HIV virus. And that HIV virus now shows up as green. So wherever you see green, there's an HIV virus, an active HIV virus. What we then did is we put this cell that's infected in the midst of a whole bunch of cells, Jurkat T cells, that are not infected. Okay?
Right.
And we wanted to see, are there other ways in which the virus is spread? And what we saw is that when a healthy cell comes in contact with the infected cell, a little tunnel is made between them, and the virus travels through into the healthy cell and starts duplicating and making another infected cell. So we also were able to discover that this is 1,000 times more effective than free virus running around and infecting new cells. Okay? So what you see in this video is the healthy cell touching the infected cell and then taking off with the virus. And we now have a lot of other images where you see these little arms almost stretching, where it's touching a healthy cell and the virus is traveling through. This happens over the span of 54 minutes in this case, and we now have a whole bunch of instances where you see this. So now this begs the question of why is the healthy cell touching the infected cell, and is there a way that we could selectively block this communication? Because this touching between cells happens all over the place. Can we somehow selectively block the ones that are infected and therefore dramatically reduce the number of infected cells?